Hi there, I'm Paul Belflem and this is Industrial Organization. This presentation is about the role of informative advertising on competition. We want to understand how competing firms choose their level of informative advertising, and to do so we will analyze the model of Grossman and Shapiro. If you want some background reading, you can read section 641 in the textbook. Right. So what are the impacts of informative advertising? Informative advertising gives information to consumers about the existence of products, about their characteristics, and about their price. Okay, so it plays what is called a constructive role. Now, the effect on firms depends on the degree of competition. If you have a single firm on the market, while giving more information to consumers about the existence of the product and its price is something good for the monopoly. Clearly, if consumers don't know about your product, you cannot make any sales. And the more consumers are informed, the more you can sell and the more profits you can make. Right. Now, this intuition extends somehow to oligopolies. It's true that it's still the case if my product is unknown by consumers, I cannot sell anything. Okay, but I need to inform them. But if I inform them about my products, they will also be informed about the existence of products of my competitors, and this will lead to more intense competition. Okay, so there are two effects working in opposite directions here. You want to inform consumers about your products, but at the same time you would like them not to be informed about the existence of the products of your competitors. But as we will see in our model, if competitors can make advertising to increase the information of consumers, consumers will know about the existence of several products, and this will lead to more competition. So the question is, what is the net effect? Will more advertising, informative advertising, lead to more profits or less profits? This is what we want to analyze now. Okay, so to do so, we will extend the Hotelling model. Remember, this is a model of product differentiation, and we use the metaphor of a unit street or unit line on which two firms are located and consumers are located around the line as well. Okay, so here we assume that the product differentiation is maximum in the sense that firm 1 is located at one extreme, which is 0.0, while firm 2 is located at the other extreme, which is 0.1. Okay, and as we did before, we assume that there is a unit mass of consumers which is uniformly distributed on the interval. So this means that we will talk about fraction of consumers. This is what a mass 1 of consumer means, and the uniform distribution means that between any distance, say between 0.0 and 0.4, there is exactly 40% of the consumers, and between, let's say, 0.0 and 0.6, there is 60% of the consumers. Okay? Now, the timing is the following. In period 0, consumers don't know the existence of the firms. Okay, so they are on the street, but they don't know that there is a shop at 0 and a shop at 1, if you want to take the geographical interpretation of the model. If you want to take the product space interpretation, they don't know that these products exist, and even less what are these products. Okay, then in period 1, each firm will set the number of ads they send and the price of their goods. So the firms make an advertising effort, which is to inform consumers, some share of the consumers, about the existence of their product. Okay, and at the same time they decide the price at which they will sell their product. Now in period 2, consumers decide to buy. They have a unit demand, so they buy 1 unit of the product or 0, but of course they can only buy products they know the existence of. Okay, so they must have received an advertising from firm I to know the existence of product I. Okay, so there are 3 possibilities, as we will see. If they've received an ad from each shop or from each firm, then they know both products and they can choose between these 2 products. They will choose the product they prefer, and this is exactly what we saw in the Hotelling model. Okay, now they may also receive just 1 ad, so they will know just 1 product, and they will buy this product. This is the assumption that we will make. And obviously, if they haven't received any ad, they won't buy anything because they don't even know the existence of the products. Okay? Now, in terms of utility, we use the same formulation as in the model we covered in week 4. So R is the base utility that consumers get, and then this is reduced by how much they've got to travel to go to the shop. It's tau times X if they go to shop 1. It's tau times 1 minus X if they go to shop 2. I'm talking about a consumer located at point X. Okay, and they've got to pay the respective price, P1 if they buy from firm 1 or P2 if they buy from firm 2. Okay, so who knows what? Okay, so what is the demand that the firms are facing depending on the effort of advertising they've made before? Okay, and the effort of advertising is symbolized by a share, lambda I for firm I, a share of consumers that have received an ad. Okay, so we make the assumption that the probability of being informed is independent of location. So what does that mean? Well, a story that fits the description would be the following. Imagine that the market is actually a long street of, let's say, 1 kilometer. Okay, and you've got houses packed along this street. So at every meter, or at every spot on the street, there is a house with the same number of consumers. Now, the companies, the two firms, they've hired people to put folders in the mailboxes in the different houses. Okay, and suppose there are 1,000 houses, and what the firms decide, so firm I would choose lambda I, which is basically the number of folders that it will print. Okay, if there are 1,000 houses, if lambda I 0.8 would mean that the firm has printed 800 folders, so that 80%, 0.8 of the houses will receive an advertising. Okay, and the probability of being informed, being independent of location, means that the people who are hired to put the folders in the houses, they do it randomly, in a sense. Okay, so they're not, they don't choose houses, they choose them randomly, and they put these 800 folders randomly in the 1,000 boxes. Okay, so this is the idea behind these assumptions. Okay, so firm I will choose this proportion lambda I, firm 2 this proportion lambda j. This is, you can also see this as the chance for any consumer to receive an ad from firm I, and lambda j is the probability or the chance to receive an ad from firm j. Okay, so the probability to receive an ad from both firms is the product of lambda I and lambda j. Okay, so these are the fully informed consumers. They are in share lambda I, lambda j, and those, as we said, they have the possibility to choose between the two firms, and we know from our previous analysis that the consumer who is indifferent between buying product 1 or product 2 has this location. Okay, so this is what we saw in the Hotelling model. Now, you can have also consumers who are partially informed. They only knew, let's say, good I. Okay, so they received an ad from firm I, so this is with probability lambda I, and they didn't receive an ad from firm J. This comes with probability 1 minus lambda J. Okay, so this is the total probability lambda I times 1 minus lambda J, that a consumer, independently of her location, has been partially informed in the sense that it has received only an advertising from firm I. Okay. Now, this consumer cannot consider buying product J because it doesn't know about it. So she will buy product I only if this is true, if the total utility at given price Pi is larger than 0. We will suppose that R is large enough, so this is the overall or the basic utility that consumers can get from any product. If this is sufficiently large, for the prices that will be used at equilibrium, this is positive, and so these consumers buy. Okay. Now, finally, there is a share of consumers who don't have any information, they didn't receive an ad from firm I, probability is 1 minus lambda I, and they didn't receive any ad from firm J. The probability is 1 minus lambda J. Obviously, these consumers don't buy. Okay, so the total demand for firm I will come from these consumers in proportion lambda I, lambda J, who are considering both options, buying from firm 1 or from firm 2, okay, plus those consumers who only know about firm I and who buys no matter what. Okay, so we summarize this here. This is the total demand for firm 1, given price P1, P2, and advertising effort lambda I, lambda 2. Okay, so consumers to buy from firm 1, they must be informed, so they must have received an ad. This comes in probability lambda 1. And there are two possibilities. Either they didn't receive an ad from firm 2 with probability 1 minus lambda 2. In that case, they buy no matter what. And finally, the last case is where they have received an advertising from firm 2 that comes with probability lambda 2, and then only a fraction of them, those at the left of x hat, will buy from firm 1. Okay, so if you replace x hat by its value, you have the total demand for firm 1. I repeat, given prices P1 and P2, and given lambda 1 and lambda 2, which you can see as the proportion of ads that have been sent by the two firms. Okay, so this is depicted here on the graph. Now, the key point here is that if there is more informative advertising by both firms, so if you increase lambda 1 and lambda 2, there will be a larger share of fully informed consumers, okay, these consumers here, and that will make demand more price elastic. Okay, so because those who care about prices are those who are informed by both firms. So if you increase the proportion of consumers who know about both firms, you have in your demand more consumers who are sensible not only to your price, but also sensitive to the price of the other firm. And that increases the price competition between the firms. This is the main intuition in this model. Okay, so what I want to show you now is just the details of the solution of the model. I will walk you through these steps, but let me just say right now that I don't want you to go into these details by yourself. I just want to give you some sense of how we will reach the final results, but this is really the intuition of this model that I want you to take away. Right? So how do we solve the model? Well, let me remind you what we do all the time now, which is to look for a subgame perfect Nash equilibrium. So we need to impose the Nash equilibrium principle at every step of the model. Okay, and to find such a subgame perfect Nash equilibrium, we solve the game backwards, starting with the last stage and then moving to the first one. Okay, so the last stage is already what we have solved, which is the decision of the consumers. Okay, now the first stage is where the firms choose both the level of advertising, lambda I for firm I, and the price of the goods. Okay, now there is one piece of the model that we need to introduce here, which is the cost of advertising. Okay, so this is given by this function a of lambda I. And we take a particular form here, which is 1/2 of little a times lambda I square. So what is important to see here is this term square. So it means that if you take the marginal cost of advertising, so if you take the derivative of this form here, well, you're going to get a times lambda I, which is positive. Okay, so this means that the marginal cost is increasing, or in other words, that it costs you more and more to increase your advertising by a constant amount. Okay, so coming back to my example before, imagine that you have 1,000 houses in your street and you decide how many folders you print to put in the mailboxes. Okay, well, if you go from 0 to 100 folders, it costs you that much. But if you compare that cost to the cost of going from 100 to 200 folders, well, the cost of the second increase from 0 to 100, the cost of the second increase is larger. Okay, so it becomes more and more costly to add more folders into the boxes of the houses in this street. Okay. Still, another way to say that is that you've got decreasing returns to scale of advertising. Right? So what are the firms choosing? They choose the level of their price for the product as well as the level of advertising, the proportion of users or consumers they want to inform about the product. Okay? And they do so to maximize their profit, which is the profit from the product itself, the margin, P1 minus C times the quantity, minus the cost of advertising. Okay, so don't get mixed up here. C is the cost of producing the product, and A of lambda I, lambda 1, is the cost of advertising. Okay, and we've got a similar function for firm 2. Right? So I'm not going to detail all the computations here. You can pause and redo this by yourself if you want to, and the details are in the textbook. But I say again, I'm really interested in you getting the intuition here, not so much the mathematical details. Okay, but just to walk you through the process, we look at the first order conditions of profit maximization for the two variables of choice, the price and the intensity of advertising. So we start with the price. This is the first derivative of the profit with respect to P1. Okay, and you can rewrite this to have the first, the reaction function of firm 1. Okay, so this is what you get. It tells you P1, which P1 to choose for any given P2. So if you look at the first part here, this is exactly what we had in the Hartelling model, but there is an additional term. And what is interesting is that the price P1 for a given P2 is higher in this case here because this last term is positive. Okay, so the firm is going to choose higher prices than under full information. Full information would be the case where lambda 2 is equal to 1. Okay, in that case, this term would disappear. But if there is only a share of consumers who are informed by firm 2, that drives firm 1 to set a higher price. Okay, and this is very intuitive. I mean, if only part of the consumers know about the product of my rival, I have some kind of monopoly position over these consumers who only know my product, and I want to exploit this by setting higher prices. Okay. Now, we also need to look at the first order condition with respect to advertising, so we need to take the derivative of profit with respect to lambda 1. Okay, this is done here. Okay, and we can then isolate lambda 1. What you need to do now is to combine this equation with the previous one, this one, okay, and also do this for firm 2. So basically you've got a system of equations in 4 unknowns, P1, P2, lambda 1, lambda 2, okay, and we solve this for the symmetric equilibrium. Firms are exactly similar here, so we expect them to set the same price at equilibrium and also to choose the same level of advertising at equilibrium. Okay, so all the details are here. These are not really complex computations, but I don't want you to go through that. I just want to finally analyze and explain the results. Okay, so these are the equilibrium levels of advertising and prices, and this is the equilibrium profits of the firms. Okay, so we just want to make some comparative static exercises. Now we want to know how these different values, lambda star, p star, and pi star, change with the parameters of the model, which are basically tau. Remember, tau is the measure of product differentiation. The larger tau, the more the consumers perceive the products as differentiated. And A is a measure of the cost of advertising. Okay, so the results are here. What do we observe? Okay, first important result, we've got that prices are higher than under full information. Okay, so under the assumption that we need to make here that A is larger than tau over 2, we see that P star, the price chosen by the two firms, is larger than C plus tau. C plus tau, remember, this is what you would obtain in the Hartelling model, where we assume that consumers are fully informed about the two products. Okay, so we already got this intuition. Suppose I'm firm 1 and the product of firm 2 is only known by a share of the consumers, not all of them. Well, that gives me more market power because there are some consumers out there who only know my product. And so I'm not competing with firm 2 for these consumers. I'm in a monopoly position. I repeat, they only know my product. So I can sort of exploit them by raising my price. And this is what happens for the two firms with imperfect information. So some consumers not knowing both products, the elasticity of demand for both firms is lower, which allows them to set a higher markup. Okay. Now, we also observe that more product differentiation leads to higher prices. If tau increases, P star increases. This is not new, okay, but the effect is still stronger than under full information. Okay, so that kind of reinforces the first observation that we made. Now, interestingly, if advertising costs becomes lower, so if it's easier for firms to advertise, that will lead to lower prices. Okay, why is that? Well, this is again the same intuition. Firms benefit here from the fact that some consumers don't know both products. Okay, now what happens if advertising becomes less costly? Well, this will naturally drive firms to advertise more. But if they advertise more, there will be more informed consumers who know about the two products, and we know that these consumers exert more competition or have the effect that the two firms compete more in prices. Okay, and so prices will decrease at equilibrium. Okay, finally, if you look at the amount of advertising, lambda star, we see that it increases when the cost of advertising decreases, which is quite normal, or when the products are more differentiated, because when the products are more differentiated, price competition is relaxed among firms, and so it costs less, in a sense, in terms of more increased competition, it costs less to increase advertising. Okay, so if we put all this together and we look now at the effect on profits, okay, what we find is that profits increase as advertising becomes more costly. Okay, so of course, when advertising becomes more costly, for a given level of advertising, there is a negative direct effect on profits. Okay, firms are facing higher costs. Okay, but in this model, this negative direct effect is more than compensated by a positive strategic effect. Okay, and this is what we saw here. That when let's put it in the other direction here, when A increases, the prices increase as well. Okay, so when advertising becomes more costly, it allows somehow firms to coordinate on lower level of advertising and thereby to set higher prices and so have a higher margin for each unit they sell. Okay, so I repeat, in this model, this positive strategic effect, the fact that higher cost of advertising relax price competition, this strategic effect is more important than the direct effect, which is negative because of higher cost of advertising. Okay, so that is the main intuition here. Informative advertising makes competition in prices tougher, and so quite paradoxically, if advertising becomes less easy to make, for example, because it's more costly, then firms are quite happy because that allows them to set higher prices and make higher profits. Okay, so just to summarize, the main takeaway is the following. Due to strategic effects of informative advertising, higher advertising costs translate into more market power, and therefore firms' profits can be higher in a market with higher advertising costs. Okay, this doesn't need to be the case, so this is what we call testable hypothesis. Okay, so we have a theoretical model that shows that it may be the case that higher advertising costs would actually translate into higher profits by firms, but this is something that we need to put to the data to confront to the reality. Okay, and for example, we can use changes in the cost of advertising. For example, with the development of internet search engines, advertising cost has become lower for firms, and according to the prediction here, this should lead to lower profits. Is it the case? This is something that can be tested with appropriate data. Okay, we can also take some confirmation from this prediction here by looking at industry lobbying in favor of the advertising restrictions. Okay, a little bit like what we saw in the video about the tobacco industry. Okay, but here the argument would be different. It wouldn't be a ban of advertising by some external authority, but firms sort of welcoming the fact that the cost of advertising increases. Okay, and you can see that some professions are imposing restrictions on their members about what they can do in terms of informative advertising. Okay, lawyers, accountants have this kind of rules. Okay, so that's it for this presentation. Thank you for your attention.